All right, in this video we're going to go over some of the practice problems from balancing equations in OneNote. And the idea behind balancing equations is that we are trying to follow the idea of the law of conservation of matter. And the idea behind the law of conservation of matter is that matter cannot be created or destroyed. So what that means is that the elements that the atoms that you start with, so the atoms at the beginning of some sort of process or change need to be equal to the atoms at the end of whatever process or change you are going through. And we can write these things called chemical equations to represent reactions that we might observe. And when we write a chemical equation, the thing that goes on the left-hand side is called a reactant. Then we draw an arrow, and then the thing that's on the right-hand side is the product of a reaction. So the reactants are the things that you start with. The products are the things that you make, or the things that you kind of end up with in a reaction. And what we should see is if we follow the law of conservation of matter, the atoms on the left should be equal to the atoms on the right. So let's take a look at an example of this. So down here with question number 1, I'm going to make a little kind of count here of the atoms I have on each side. I'm going to make a T chart, and I'm going to count. And I'm going to see over on the left, looks like I have atoms of Fe and O. That's iron and oxygen. And over on the right, I also have atoms of Fe and O. So we seem to be starting out pretty good. We've got the same elements on both sides. Now we're going to stop and count and see how many of that element we have on both sides. So over on the left, we've got 1 atom of iron, and this number right here is called a subscript. This tells you that there are 2 oxygens. So I've got 2 atoms of oxygen on the left. Over here on the right, I've got 3 atoms of iron, because that's the little subscript is telling me, and I've got 4 atoms of oxygen. So I have the same elements on the left and the right, but I don't have the same number of these elements. I've got too many irons over here and too many oxygens. So is this equation balanced? If I were asked that question, I'd say no, it's not balanced, because the number of iron, I'll pick one example, the number of iron on the left is not equal to the number of iron atoms on the right. Okay, so if I decide that an equation is not balanced, I can try to balance it by adding something called a coefficient. And a coefficient is a number that would go out in front. So, for example, over here, I have 3 atoms of iron on the right, but only 1 on the left. So to make these equal, I need 3 irons over here as well. So what I can do is I can stick a coefficient out in front. And that means you have 3 of whatever follows it. So when I'm balancing, I can only add the coefficients. So I balance using coefficients. And again, the coefficients are the number that comes out in front. So like if I were to have 2 water molecules, this number right here is what we call a coefficient. Okay. So if I put a 3 out in front, that means I have 3 irons. And then I also need more oxygens. I need double the amount of oxygen. So I'm going to put a 2 in front of here. So what that means is when I have 2 O2, what that means is I have 2 O2s. So if I add that up, how many oxygens do I have? It's 2 plus 2. I have 4 oxygens now. So now my equation is what we say balanced. So I added this coefficient, made my equation balanced. Now I have the same number of atoms on the left and on the right. Let's look at another example down here. This equation, on the left I have Sr, which is strontium, and I have O, which is oxygen. And I've got the same thing on the right. I have Sr and I have O. So on the left I have 1 atom of Sr and 2 atoms of oxygen. On the right I have 1 atom of Sr and 1 atom of oxygen. So it looks like I need more oxygens over here. So I'm going to put a 2 in front of the SRO. So when we're balancing, we can only change the coefficients here. Because right now this equation is not balanced. Okay, so I'm going to try and balance it by adding coefficients. So if I have 2 SROs, what that means is I have an SRO, and I have another SRO. So if I were to count, notice I have 2 oxygens now. I also have 2 atoms of SR. So they both changed. Okay. Over here on the right, now my oxygens look good, but now I don't have enough SRs on the left, so I need another SR, so I'm going to put a 2 out in front. Now I've got 2 SRs. All right, let's look at another example. Let's look at number 4. In this one, I start counting. I've got 1 atom of K on the left, and I have 2 atoms of chlorine, that's Cl. On the right, I have 1 atom of K, and I have 1 atom of Br. So here you might notice, like, wow, this is definitely not balanced. I don't even have the same elements. This is bromine, this is chlorine. So this one is not balanced, and this one's going to be impossible to balance. This one's no reaction. All right, hope those examples helped. Thanks.